Hi students, this is a quick recording for Biology 1407 Lab. I'm showing you an illustration out of the prep manual for this particular laboratory, and I want to call your attention to this little representation of a gel right here. So this is meant to be an electrophoretic gel that we normally use in our physical lab and that you would have simulated in your week 2 laboratory and then done some analysis of in your week 3 laboratory, the results of. So once you've finished amplifying selected DNA using the polymerase chain reaction procedure, that purified and amplified DNA is put inside a well in a gel right here. A well is just a hole, so there it is being dipped in using the pipetter, the micropipetter. And then the idea is the positive charge drags the DNA, which is negatively charged, towards the positive pole. And the idea is that the smaller pieces of DNA are going to go a longer distance, and heavier, larger pieces of DNA are going to go a shorter distance. And so what you'll end up with is DNA that's sorted out moving down this gel based on its size. And so I've set up a situation right here where we've got 3 different individuals, and each of these represents a different student individual right here. And so in the first case, the DNA moves a great large distance and creates a block right here. For number 3, there was nothing in number 2, but in number 3 right here, the DNA moves a shorter distance because it's heavier. And in this individual number 4, they've got both. So they end up with a block of DNA that's moved to this position right here and a block of DNA that's moved to this position right here. And that represents the 3 different possible outcomes of the ALU experiment. If you don't have that ALU transposon inserted in a piece of DNA, the part that we copy is going to be smaller, and all of the DNA that's copied is going to move a greater distance, like this individual right here. So we'd say that individual is minus, just meaning they don't have ALU on either chromosome, the copies that we sampled. This individual right here has the ALU insertion on both chromosomes. How do we know that? Because the amplified section is big and only moved, a shorter distance. So we'd label this individual plus. All right. And then finally, the 4th position right here, that's the individual who on one chromosome, copy A of chromosome number 16 in all the cells of their body, has the ALU insertion, so that's this right here, but on the 2nd chromosome, the one they got from their mother, let's say, but it could be their father just as easily, there was no ALU insertion, so the amplified piece of DNA there moved a longer distance because it's a smaller bit of DNA. This individual is plus minus. All right? Good. So now we'll go ahead and take a look at the, let me clear this. So here is a schematic of that situation right here, and here's a piece of gel representing the schematic. So here we've got our first primer, and here's our second primer, and so the idea is that we're copying all of this DNA from here to here, including the ALU insertion inside it. Now, if that ALU insertion is not there, the same piece of DNA that we copy is shorter. And that equals this bit right here. This longer piece equals this bit right here. So now if we go ahead and look at a gel, and let me magnify this a little bit. All right. This one's got information on 3 different students. All right. And then it has markers. This is just basically a pile of pieces of DNA of known sizes, including 730 base pairs and 416 base pairs right here, that we can put in to provide a ruler function in gel electrophoresis. And just for those, it's not important for y'all right here, but if you look at these numbers carefully and you're mathematically inclined, you'll see that this is a log scale. So, 10 1 base pair long, 10 base pairs long, 100 base pairs long, 1,000 base pairs long, 100,000 base pairs long is the way a log scale goes here. So the biggest pieces will be up at the top, the smallest pieces down at the bottom anyway. So here we have an individual who all of their amplified DNA moved the longer distance. And that means it was smaller bits of DNA. This individual, all of their DNA that we copied moved the shorter distance, which means it's a bigger piece of DNA. And then finally, this individual right here has both. And so this is the plus minus individual. This is the plus plus individual. And this is the minus minus individual right here. And that's how you interpret a gel. So in this particular case, if I made a table, where did this go here? Let's try this. All right, so if I make a table and plus plus, you'll have to forgive me, I'm not very good with using this software yet. Whoops. Erase. Whoops. So plus 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 minus, minus, minus. We'd have one individual for each one of these particular cases right here. All right, let's see if I can make this go away. I can't seem to shrink it down, but that's the idea right there.